Statistical Rethinking, second edition, chapter 15. And we're on the last medium difficult question, question 15, M6. Okay, so if you're going to use this Colab sheet, you got to make sure that you have gone up here to change runtime type and make sure that you're in R. And of course, there's code way up top here that installs all of the necessary software, so you'll have to run that. Okay, so we're returning to the chapter where we have these dog eats homework missing data examples. Okay, and there was 4 of them, and we'll go through each of them here. And so we're going to simulate some data for the different situations and then try to recover the appropriate coefficient that describes the relationship between S and H, which is, I suppose, the student. So, okay. So all of them are going to use, well, not necessarily, but let's just get this chunk out of the way. So we're going to simulate some data. So I'm going to have 100 observations, and S is going to be a normal distribution, and then homework is going to have, so it's maybe 10 questions, and they got some amount right, and we're going to sample how many they got right out of, a binomial distribution there. Okay. So the first one is the simplest one, and this is called MCAR, or missing completely at random. There's a little blurb in a blue box in the chapter that describes these naming conventions. They're not incredibly intuitive, but I guess I'm using them here just to, connect to things outside of the book. Okay. So now, so what's happening here is, so the missing mechanism here is dog. Okay, dogs are eating homework. Okay, but there's no open path between the missingness mechanism D and homework here. Okay, so dogs are eating homework, but therefore both the actual homework and whether or not there's dogs are affecting H star, which is the observed score of the homework. Okay, but that missingness, the dogs are just eating homework at random. Okay, and so just without thinking about this, we might just think, oh, well, if they're just eating them at random, then the missingness should just be, more or less fairly distributed across all students' homeworks. And so it's almost like just having a smaller sample of students to find, the average score of the homeworks. Okay, so so in this case, so we're going to create that data here. Okay, so I have dogs. So this is all just taken directly from the book here. Okay, but we have dogs, and they're just randomly eating homework, 1s or 0s here for D, and then we're going to select the data where well, what do I want to say here? We're going to have homework that's missing where D equals 1, and we're going to set those values equal to NA, and then we're just going to simply observe the values that are not NA and HM, which means the observed values. Okay, so I have my data here. Okay, and if I just run this particular model, I've already ran it. It runs just fine. And we get our coefficients here, and the coefficient here is 0.82. Now the book tells us, and you can do some math to demonstrate this yourself, but it's not important to the problem here, but that the expected value should be 1 for that coefficient. It's within 89% of the credibility interval. I suppose it's an okay estimate. Okay, so let's move on. So the next one is called, the next 2 mechanisms are called missing at random, which is different than missing completely at random. Okay, so as the book describes, these are very kind of bizarre naming conventions here. So in this first MAR, okay, we have a relationship between S and D. How do I want to say it? There's an open path between D and missingness here. Okay, and homework, or missing homework here. The actual homework, I mean to say, right, goes S to D to that. And so if I want to block that path here, I just simply need to condition on S. Okay, so so that's what we're going to do. So again, now I need to generate some new data for this. And so I need to make a connection between D and S. And so I'm just arbitrarily, well, not arbitrary, the book describes how to make this data. But notice I'm tying, the missingness, dogness, to S here, right? So values greater than S, have whatever. Okay, so anyway, so if I go through the same thing. I select the observed values given my new value for D. Okay, I run those, and so my model here. Remember, in order to close this connection between D and the actual homework, I need to condition on S. So this is my model, but this is exactly the same model that we had above here. Okay. All right. So when I run this, it runs just fine. And now I get an estimate of 0.71. Again, this really isn't a great estimate. This should give us an unbiased estimate, and perhaps if we had a larger sample size, we would do better. But this should work. And in fact, if you run this model several times, you often get better estimates than this particular one. Okay. So now for the second type of missing at random, again, where there is a connection between the missingness and the missing homework. What was proposed in the book is this kind of a DAG here, where there's some mechanism, unobserved variable X, that is connecting the actual homework that we don't observe and dogness or missingness here. Okay, so again, we create some new data here. Okay, and so again, this is copy pasted from the book. But what's important here is I've created this new variable here, but again, remember, we don't get to observe it. So even though I've created it, we're not going to use it. And then I am creating my missingness, my doggedness, based on that value of X. Okay, so now there's a connection between D and X, and also between X and H. Right, so here's H, and I'm defining it as a function of X. Okay, so we go through and we run the model, and this is our estimate. And so this doesn't seem to be that much worse than the other two, although if you look at the credibility intervals, it is a little bit farther away. But I suspect that if you were to run it several times or to tinker with exactly how you generated the data, this would get worse. And the lesson from the book here is that there's probably nothing we can do here, right? Because in order to close down this path, I would need to be able to condition on X. But here, we're saying that we can't observe X. And so I can't condition on it. And so that biasing pathway is always going to be there. Okay. Now, the final mechanism is missing not at random. But that's described by this DAG right here, where now the value of homework, the actual homework, not the observed homework, is directly affecting doggedness, right? So here I say that less than homework that is less than 5 is causing missingness. Okay. So, but again, what's important here is that now missingness is a function of the homework, okay? And so now we run this again, and now we get a coefficient that is very far away, okay? And this is to be expected. And again, there is nothing that we can do to close this pathway, and so we're just stuck with this heavily biased estimate. But in a way, that's not the worst case scenario, because if we know that this is the case, then we know that this model is not reliable, right? And you could do some simulations if you had some hypotheses as to what causes D to be triggered by H and so forth. But just in this example here, we're kind of we're stuck. But it's okay as long as we know that we're stuck, and therefore the estimates are not reliable. So yeah, okay. So I think that is it.